So let's see how we can add some lose conditions to our game now. Currently, whenever our play field gets too small, the game just keeps going and there doesn't really seem to be a way to restart the level or whatever. We just have to close the preview of the game being played. But in this chapter, we're going to see how we can uh, reload our scene to start over our game. This will be the first step into creating a series of menus that will allow us to start our game and lose and restart with different kinds of conditions. Like, do you want to restart your game? Do you want to add a second player? Things like that. Before we can get to that, we got to be able to have a lose condition. So why don't we go ahead and see what we have figured out for us. I'll move this right over there. All right, so in this scene, I have two new variables called area health and area death health. All right. Area health will be a constantly updated value that will give us a normalized figure or normalized value for what the health of our play area currently is. We're going to treat our square play area like it has its own health bar, because essentially that's basically what it is. It has a health. Being at maximum health has a large play area. Being at smaller health values will denote a smaller play area for the player to navigate in. And our player death, rather our area death health right here, will indicate at what value will the size or scale of our boundary play area denote a lose condition. So why don't we go ahead and see what's going on here. And to speed up this demonstration, I'm going to increase the boundary shrink amount to 2. So when we press play, we can see we can get closer to lose conditions. All right, so we've got our play area really small right now. I'm going to change my boundary amount back to 0.1 while it's paused. And we can see right now we have an area health of 0.2 health. So if I let it keep going, if we look at this value over in our right-hand corner, our area health, we can see it starting to shrink. And when it reaches below 0, then our game will restart like so. So our play field's really rapidly shrinking, and we're just starting over and over again. Of course, this isn't balanced gameplay. For demonstration purposes, I've shrunk the value of our boundary here. I'm shrinking the boundary of our play area rapidly right here. All right, so why don't we get started with how we can achieve this? So it's going to be a rather short video. We only have really 3 main things we have to do in this video. The first thing we have to do is calculate the play area's health on a normalized 0 to 1 scale. So if the area had 100% health, its value would equal 1. And then it would the health would drop in decimal points all the way down to 0 for a lose condition. Then we have to constantly be checking if our play area's health drops below lose conditions, which will be the value in which our player will not be able to move around anymore. Basically, when the walls have closed in and around our player. And the third thing we're going to have to do is we're going to have to make a game over function that triggers all the types of arguments or logic that we want to do whenever our play area's health drops below our lose condition. So in this video, our game over function is just going to reload our scene. And in later videos, we're going to expand our game over function even more. All right, so let's just jump into our code right now and see how we can achieve this. All right, so we're only going to be working in our game manager script. So I'm going to go ahead and double click on my game manager script and just get it open here. All right, so the first thing we have to know is we already have a value that's given us our current size of our play area. And our boundary scale value right here is constantly giving us the scale of all 4 of our boundaries right here. So our scale, when we go ahead and play, and I'll let it shrink. So if I pause it, we've already shrunk a little bit. This Z value right here is actually our boundary scale value. We can't see it in our game manager because it's a static variable, meaning that it's accessible universally throughout our game, but also means it's not exposed in our attribute editor or in our inspector rather. But just know that this z scale value is what we set our boundary scale variable to a few chapters ago. So this is going to be the main value right here we're going to be working with, and I'll zoom in so you can see that. This z value right here. And that's going to give us the current size of our play field. All right. So what are we going to do with this value? Let me zoom in a little bit. Well, our value we saw earlier was at 19. Well, when we start out, our value is at 20. That's not a very good indication of how much health we have. Sure, we could hard code it and say, okay, our maximum health is 20, and when it gets below 1.5, then game over. What we're going to do is we're going to do something a little bit more advanced than that, a little bit more eloquent. We're going to normalize this value between 0 and 1 so we can get a universal kind of figure for the health of our boundary. And this will kind of work with whatever shape or size any boundary in the future you want to work with might be. All right, so we have, I've mentioned normalize before. So what does normalize mean? All right, well, let's just zoom in here. To normalize any value, we have to have three different figures. And when a value is normalized, its value can only be between 0 and 1. So it'll be a decimal, like 0.8, 0.253, 0.1, 0.05, things of that nature. Decimal points in between 1 and 0, which basically equals to, a nice scale between 1 and 100 if you want to think of it that way. But basically, we're just changing any value, whether it be 20Z scale or 13Z scale in our inspector that we had over there a second ago, right up here. And we're just normalizing it. We're making a relative value. So to normalize something, we need three different values. We need the current raw value of the number we're trying to normalize. And in this case, it'll be our boundary scale value. And then we're going to need the maximum value in which our normalized boundary scale could be. So our maximum value is going to be basically the max health of our boundary, which will be the starting scale of our game area, the starting scale of our boundaries. And then we need the minimum number our value can be. So the minimum health before we lose, which will be, if we look in our game view over here, if we shrink it, then we're looking for maybe if our cube, if our player is of 1 unit size, then maybe our boundaries need to be 1 unit, and that way that'll be totally encompassing our hero. So our minimum value for our play area will be 1. Okay. So just to go through that again, whenever we start up the game, our maximum value is going to be set to 19.4. This is the most our boundary will ever be. All right. Right now, it's also currently the value of our boundary scale. But if we hit an obstacle, our maximum value is still going to be that 19 value. But since we've hit some obstacles, our current raw value of our boundary scale or our player health is now 18.2. And if we get hit enough, and I'm going to pause the game and let this game kind of knock me down all the way to where I'm almost about to lose. I'll be right back with that. So I'm back with that same gameplay. And what we see now is a vastly smaller play field. And if we click on one of our boundaries right here, we can see that its scale is now 3.1 over in our inspector here, 3.19. So basically, we're living in an area that's about, I don't know, 3 units square, 3 square units. So I'm going to go into my game manager, and I'm going to adjust my boundary amount. Right now it's 0.3. Let's just adjust our boundary amount to 0.1 and press play. So we're shrinking. All right, so right there, that's pretty much a game over. And we can even do it to where the square completely collapses on itself. And now we can see that our scale amount is way below 1 right here. And in fact, what if we set our z scale to equal to 1? Hmm. Well, I guess that doesn't matter because we have to also adjust the position of it. So let's just yeah, it's kind of hard to show that without also having to move my boundaries. So the relationship, yeah, you see, we're getting our game area all out of whack. But we could see that as soon as our skill value dropped below 1 or so, it was pretty much game over for our character. He couldn't move at all. So by playing the game, I can kind of get a feel for, you know, the smallest our boundary could get before I say, oh, game over time. So that's going to be our minimum value. So remember we were talking about those three values right here: our current raw value, our maximum value in our normalized range, and the minimum value in our normalized range. So basically we're saying that we're trying to figure out a relative value of our current health between the max health and the minimum health of our play area. And there's even an equation to normalize something. So the normalized value will equal our current raw value minus the minimum value it can be, divided by the max minus the min. So we can translate this equation here straight to our code. So we need a few new variables right now. So why don't we go ahead and make these real quickly. So I'm going to come up here in my game manager script right up here, and I'm going to make a few new public floats. I'm going to say public float area health. This will be our normalized value that'll show us currently how healthy our play area is. We'll do another public float, and this one we're going to make this a public float area death health, so we can have a little bit more control over how small you want the area to be before you call game over. All right, we could hard code it to be a certain value, but exposing this in the inspector will give us a little bit more flexibility on when we want to call the game over. At what size of our game area do we want to say the game is over? And then we'll go over here to our private variables that we've defined over here. I'm just going to add a float called area start health. This will act as our maximum value in our normalization equation I showed you a second ago. Before we can get into the math of normalizing our health of our level, though, whenever our game first starts and our void awake, we have to say area start health equals our boundary scale. This will give us our maximum health, the highest, healthiest, largest value our boundary will be throughout the whole game, because our boundary is never going to be bigger whenever we start, like when we start our game. So when we start our game, our boundary is going to be at our biggest, so it'll be at our maximum health. So that's when we'll set the current scale of our level to our start health. That'll be very important in the equation down here. So in our void update function, let's use the equation now. We're going to say area health, which is our normalized value, will equal our current raw value, which is boundary scale, minus area death health, which is our minimum, divided by our area start health minus our area death health. That's that same normalization equation that I showed you a second ago. All right. And that's really all we have to do to get a normalized value for our area health. And here you can see area health. I'll zoom in on the inspector here. Here you can see our area health is at 0. That'll update as soon as we start the game. And we need to define what our death health will be, which will be 1 unit. All right. Whenever our boundary scale goes below 1 unit, then we'll restart the game and the game will be over. So why don't we go ahead and play this and we can see it in action. All right, our area health automatically goes to negative 18.4. And that is wrong. We wanted a value of between 0 and 1. So let's see what we did wrong in our math, and we can go back and really nail down this normalization equation. Okay, looking back through the code, this is gonna make you go, what? The reason why we weren't getting a 0 to 1 normalization of our area health is because we typed in our area start health in the wrong. We needed to shrink our boundary first, and for whatever reason, I don't like our game hadn't figured out the correct starting health of our playfield until we fire that shrink boundary function that one time. I remember a few videos ago, we shrink our boundary once to get all of our values set up just perfectly. Well, if we set our starting area health after we've shrunk our boundary, then we'll get the correct type of math going on. Yeah, I couldn't believe it when it happened either. So now we get an area health of 1 right there. So now when I occur penalties, now my area health will be adjusted by 0.9. I'm trying to think why that logic happened like that. Like, why did we have to do that shrink boundary first? And I don't. I could go through and try to figure it out. Let me see if I can real quick. I'll pause this and see if I can figure out why the code did that. And I figured it out. Basically, what was happening was our boundary scale didn't update its value at all. It didn't have a value assigned to it at all. So it was basically 0 until we call our shrink boundary. And here you can see boundary scale. You can see now that its value is being set to the scale of one of our boundaries. So basically, we had to shrink the boundary to get the correct scale of our boundary right here before we could actually set our starting area health to our boundary scale. So basically, it was starting out that our area start health, let's just say that if it was when it was up here, area start health equaled 0. When it's down here, area start health now equals like 19 point whatever. So that was the difference there of the logic there, and that's just kind of chalking up to setting up a few functions earlier in your game. So keeping track of what your game is still doing, what kind of logic and arguments your game's doing, even if it's a few weeks down the line when you're programming it, that'll help you save a lot of heartaches there. Luckily, I was able to figure that out pretty quick because our game's a little on the small area. So that's why that error happened right there. But we got it fixed, and now our area health is normalized between 0 and 1. So meaning as soon as we take damage, our health is going to go into the decimal world. All right, great. So eventually I'll get hit enough where this area health value will dip below 0. And I'll pause it and come back to when it's just about to go below 0. All right, sorry for the pause there. So basically, we have to check our players' play area's health with a conditional statement that checks and see if our area health value over here in our inspector drops below 0. So let's just bring up MonoDevelop, and inside of our void update, why don't we pick a good place to do that? And I'm going to do it right underneath where we figure out our area health. So we have a few other things going on down here with our timers and our checkpoints. But before we get into that, before we can even hit a checkpoint, why don't we check and see if our play area is healthy enough to keep continuing with the checkpoint system we made last chapter. So we're going to say if area health minus equals 0, then what happens? Well, let's call it game over function. And we haven't made a game over function, so it's pink. So what we're going to do is we're going to come down here. So right before we do our shrink boundary, I'm going to call a void. Now I'm going to make my game over function. Make sure you get the spelling correct. And for right now, why don't we just reload the current level of our scene? Now there's two ways we can do that. But before we can get into scene management, we have to add a new library to our game. So at the very top, let's say using Unity Engine dot scene management. That'll give us access to a few special functions that allow us to load scenes and pass data between scenes. Basically, a library that allow us to use the functions we're going to be using in a second. So in Void Game Over, the first way and the easiest way is just to reload the current scene we're on. And remember, we're just reloading our scene in this video. We'll get into loading game over scenes or displaying different UI messages in our next few videos here. But for right now, let's just reload our scene. Let's say scene manager dot load scene. And then we're just going to use a function that points at the current scene we're in. So we're going to say, what scene do we want to load? We're going to say scene manager dot get active scene. And since load scene asks for a integer value, it actually asks for an integer. So this right here needs to be turned into a number. We'll say build index, and that'll give us our integer value. All right, so we're basically calling on the scene manager library, and we're going to use the load scene function within that library. And we're going to use our scene manager function to get our active scene, and that'll give us the name of our scene, and then we're going to do a dot build index to give us the integer number of our scene. So scene 0, scene 1, scene 2. We'll hit Control S to save. And for testing purposes, I'm going to go down to my boundary amount here and just make it 2, make it a really high number. So I can go ahead and kind of sink the boat here. Okay, so we loaded our scene, and you'll instantly see that something is wrong here. Our lighting got all messed up. Well, this is a weird little bug that happens only within our scene game preview window. If we built this out as an executable file, I don't think this lighting error would occur, but it kind of makes testing the game a little bit weird right now to see the light change like that. So why don't we go ahead and just fix that? And the problem lies within our global illumination value, the lighting trick that adds a nice full light within our scene, makes it a little bit brighter. So that's not carrying over to our scene because we haven't baked our global illumination lighting information yet. So if you don't quite understand what I'm talking about, we haven't gotten the lighting yet, that's fine. Just follow me now. Know that our global illumination needs to be baked into our scene. So when we load scenes within our game here, it'll stay with us. So we'll go to Window, Lighting, then we'll go to Light Maps over here. And the light maps, we'll uncheck Auto Build, and then we'll hit Build Manually. And it should take really quick since our scene's very simple. Now we have lighting built into our scene, as you can see right in our scenes folder, test scene. We now have a folder called test scene, and now this holds our lighting data, our global illumination data right here. So it'll be able to call on this folder here to keep our light going in between scenes. So to prove it, why don't we go ahead and just kill ourselves, run into some obstacles. And then the next one should do us in. And there we go. We reloaded our scene. Our line information stays the same. All right. So that's one way in which we can reload our scene. Why don't we manually load whatever scene we want? So instead of this scene manager get active scene, I'm just going to have it call scene 0. All right. But what is scene 0? How do we say, okay, my test scene right here, this is what I've called my game scene. Since this is mainly an R&D type project, I decided to call this scene test scene. I need to say test scene is the scene I want to reload. And but I'm calling scene 0. How do we correlate those two things together? Well, we'll go to File, Build Settings, and this is this window right before you export your game as an executable file. But we're not going to export our game. What we're going to do is we're going to check our little box here that says every open scene that I'm working in Unity. I only have one scene open right now. We're going to add all the open scenes to the scenes in the build. And if I highlight test scene, look over here to the right. We get a little integer value right now. We basically said that our test scene is now scene 0. And we can just X out that window. And things should still be the same. So let me kill myself. So instead of using the scene manager, get active scene, we're just going to say load scene 0, which is our current scene we're working with. All right. So that is basically the video here. The main thing we've achieved is giving ourselves a area health value here, and we've achieved in creating a game over function that we'll be able to trick out and expand upon in later videos when we start getting into UI. All right, thanks guys.